This is the OCR GCSE 91 Maths Paper 6 from the June 2018 series, and this paper is a calculator paper. Question number 1. Ping chooses 4 numbers. The mode of these 4 numbers is 8, the range is 7 and the mean is 11. We have to find Ping's 4 numbers. Well, let's begin by thinking about the mode. So if we think about the mode, well, if I have 1 8, this situation will not work because the mode is 8. I need at least 2 of the 4 numbers being 8. Now, if I have, say, 4 8s, like so, the mean will be 8, the mode of course is 8, the range is 0. So I can't have 4 8s. Let's think about having 3 8s. Well, if I have 3 8s and the range is 7, the range is the biggest number take away the smallest number. So for me to get a range of 7, well, I've got the biggest take away the smallest, which is equal to 7. Now suppose 8 is the biggest number. I've got 8 take away the smallest number equals 7, which means in this case the smallest number is equal to 1. So if I have my numbers 8, 8, 8 and 1, clearly here the mean will not be 11. So this will not work. Let's try working that out the other way. Suppose we have the biggest number, which we don't know, take away our smallest number 8, and suppose this is equal to 7. That means our biggest number is 15. Now will this work? If I have 8, 8, 8 and 15, will that work? Will this give a mean of 11? Well, clearly not, because if I do 8 plus 8 plus 8 plus 15 and then divide by 4, I will not get 11. So that means there must be 2 8s. So we've got so far 8, 8 and 15. How do I normally work out the mean? Well, I work out the mean by adding all the numbers together and dividing by how many numbers there are. So if I think about the mean, I add all my numbers together, so I've got 8 plus 8 plus some other number, we'll call it x, plus 15, and then if I divide all of this by 4, because there are 4 numbers, it will turn out here I will get 11, which is my mean. So if I do 11 times by 4, I get 44. So I've got 8 plus 8 plus 15, that's 31. So I've got 31 plus x equals 44, which means x is equal to 13. So my four numbers, I've got 8, 8, 13, and 15. Question number 2. A box contains only red, blue, and green pens. The ratio of red pens to blue pens is 5 to 9. The ratio of blue pens to green pens is 1 to 4. We have to calculate the percentage of pens that are blue. So we've got this table here which shows red, blue, and green. The ratio of red to blue is 5 to 9. So we have 5 to 9. Blue to green, that's 1 to 4. So to find out the ratio red, blue to green, well, we see that the blue is common to both and we want the blues to be the same. Here I've got 9, here I've got 1. The lowest common multiple of 9 and 1 is 9. So to go from the 9 to the 9, I multiply by 1. 5 times 1 is 5. 1 multiplied by 9 is 9. 4 times 9 is 36. So, to find out the total is 5 plus 9 plus 36, which is equal to 50. And therefore, we have 9 over 50, which is the fraction that are blue. And to convert this to a percentage, we multiply by 100. And it turns out we get 18%. Question number 3. Asha worked out 326.8 multiplied by 6.94 subtract 3.4 all over 59.4. She got an answer of 19.5 correct to 3 significant figures. Write each number correct to one significant figure to decide if Asha's answer is reasonable. So, what we have over here is the following. Well, we've got the 326.8, which to one significant figure is 300. And then we multiply this by what's in the bracket. And to one significant figure, we've got 7 subtract 3 all over 59.4, which is approximately 60. So let's work this out. I've got 300 over 60, which is 5, and then I've got 5 times by 4, which is 20. So we get an answer of approximately 20. So this 20 is a reasonable answer, and that's because 19.5 is close to 20. Question number 4. Part A. Show that a to the 5 multiplied by a cubed squared can be expressed as a to the 11. So, we have a to the 5 multiplied by a cubed squared. So here I've got a, now here I've got 3 multiplied by 2. So I've got a to the 5 multiplied by a to the 6, and because I'm timesing and I've got the same bases, I would have to add the powers. So I have a to the 5 plus 6, which is the same as a to the 11, and that's what I wanted to show. Part B. Write 1 over 125 times 25 to the 9 as a power of 5. We have to write the 125 and the 25 as a power of 5 to begin with. So what we have here is 1 over, now here we've got 125, which is the same as 5 cubed, and then I multiply this by 25 to the 9. Now 25 is the same as 5 squared, and then I raise this to the power of 9. So I've got 1 over 5 cubed, which is the same as 5 to the negative 3, and I multiply this by 5 squared to the power of 9, which is the same as 5 to the power of 2 times 9. So I've got 5 to the negative 3 multiplied by 5 to the 18. And I've got the same base and I'm multiplying, so I need to add the powers. So I've got 5 to the negative 3 plus 18. So I've got 5 to the power of 15. Question number 5. The diagram shows a straight line that passes through the points A and B, and a curve that passes through P and Q. And that's what we see in this diagram. Part A, we have to find the equation of the straight line. This is our straight line. To find the equation of that straight line, we need two things. We need the gradient and the y-intercept. The y-intercept, that's straightforward, that's just 2. When x is 0, y is 2. It's where the line passes through the y-axis. Let's find the gradient, and we can find the gradient by considering these 2 points. The gradient, that's equal to 5 subtract 2 over 4 subtract 0. So the gradient of the line, that's equal to 3 over 4. So this is our gradient. We know what the y-intercept is, so we can state the equation of the straight line. The equation of the straight line, that's given by y equals 3 over 4 x plus 2. So that's the equation of the straight line. Part B, the equation of the curve is y equals x squared plus kx plus 8. We have to find the value of k. We can find the value of k by substituting in this point P. So let's consider the point P. P is negative 4, 12. So we've got 12 equals negative 4 squared plus k multiplied by negative 4 plus 8. So what do we have here? Well, I've got 16 plus 8, which is 24. So I've got 12 equals 24 subtract 4k. So 4k is equal to 12, which means k is equal to 3. And knowing what k is, we can therefore conclude that the equation of the curve is given by y equals x squared plus 3x plus 8. Part C. Deanne draws line BQ. She says ABQ is isosceles. Is Deanne correct? You must show your working. Well, what we need to do is find the point Q. And we can find the point Q by considering the y-intercept of this curve, which is 8. So, Q would have coordinates 0, 8. So, Q has coordinates 0, 8. Now what they are saying is ABQ is isosceles, so two of the lengths must be the same. So, for this triangle to be isosceles, let's think about the length AB and the length QB. So, if I find the length of QB, what I have is the change in x's. So the change in x from 0 to 4, that's just 4. So I've got 4 squared. And the change in y's, I'm going from 8 to 5. So that's negative 3. And then a square. And then I have to square root. So if I work this out, I get 5. Similarly, AB will have to consider the change in x and the change in y. So I'm going from 0 to 4, so that's just 4. And I've got squared. Then I've got the change in y. So I'm going from 2 to 5, so that's 3. Then a square. And then I square root. And it turns out we get 5. So because these are the same, we can therefore conclude that ABQ is isosceles. Question number 6. Y is inversely proportional to x. Y is 0.04 when x is 80. We have to find the value of y when x is 32. Well, if y is inversely proportional to x, that means that y equals k over x. So, when x is equal to 80, y is 0.04. So I've got 0.04 equals some value k over 80. So if I work out the value of k, that's 0.04 times 80, which is 3.2. So in other words, y equals 3.2 over x when x equals 32, y equals 3.2 over 32, which is 0.1. So y is equal to 0.1. Question number 7. Edsel has 4 number cards, 3, 8, 9 and 12. Sharon has 3 number cards. U represents a number that Sharon knows, so we've got 11, 6 and U. Edsel and Sharon each pick one of their cards at random. They calculate the difference between the numbers on their cards. This is their sample space. We have to work out the value of R and T. Now what's happening over here? We've got the 6 plus 3, which is 3. 6 plus 8. Well, that's not 2, so what they might be doing here is taking away. So we've got 6 take away 3, which is 3. And then we've got 8 take away 6, which is 2. 9 take away 6, which is 3. And then 12 take away 6, which is 6. So that's what's happening there. So for us to work out the values of R and T, well, for this, what we would need is the value of U. So something take away 3 is 11. So I've got U take away 3, which is 11. So therefore, U equals 14. So I've got U, which is 14. So let's think about how we can work out what R and T are. Well, to work out what R is, I would have 14 take away the 9, which is equal to 5, which means R is 5, and I also have 14 take away 12, which is 2. So T is 2. So I've got R is 5, T is 2. Question number 8. The graph shows the speed of a tram as it travels from the library to the town hall. Part A, calculate the deceleration of the tram as it approaches the town hall. Well, that will be the gradient of this portion here. So this is what the deceleration is given by. So we've got the negative, and the reason we've got negative is because we've got deceleration. We've got change in y, which is 6, over change in x from 65 to 85, that's 20. So we've got 6 over 20, which is negative 0.3. So I've got negative 0.3 meters per second squared. Part B, calculate the distance travelled by the tram between the library and the town hall. So for this we have to find out the area, and for us to find out the area, what we can do is work out the area of this triangle. So the area of the triangle is 1/2 times 85 multiplied by the height of 6. So I've got 85 times 3, which is 255. So I've got 255 meters. Part C. What is the maximum speed of the tram as it travelled between the library and the town hall? Give your answer in kilometers per hour. Well, the maximum speed is where the speed peaks, which is here. So that's where the maximum speed occurs. So therefore, that's given by 6 meters per second. And what we need to do is convert this into kilometers per hour. So what I need to do is take the 6 and then I multiply it by 1/1000. That converts it into kilometers. And then for the seconds, I have to multiply by 1/3600. And that converts it into seconds. So what would I get over here then? I would get 21.6. This converts it into hours. End up with 21.6 kilometers per hour. Question number 9. The graph of y equals x cubed subtract 7x subtract 12 is shown below. The root of the equation x cubed subtract 7x subtract 12 equals 0 is p. Part A, calculate y when x is equal to 3. So let's see what happens when x is equal to 3. We have to replace the x with 3. So in this case, y is equal to 3 cubed subtract 7 multiplied by 3 subtract 12, which is -6. So y equals -6. Part B, show that p is greater than 3 but less than 4. Well, we know that p is a root of the equation. So what we have to do here is begin by letting f of x equal the equation y. So we let f of x equal x cubed subtract 7x subtract 12. So the first thing we can do is see what happens when x is equal to 3. In other words, find out what f of 3 is. F of 3, well, happily for us, we've already calculated that. That's -6. Let's now find out what f of 4 is. We replace the x with 4. So I've got 4 cubed, subtract 7 times 4, subtract 12, so that's 24. So what we're saying here is, when x is 3, y is -6. When x is 4, y is positive 24. So, what can we say then? We would say then, as f of x is continuous and we have a change of sign, we have, therefore, p being between 3 and 4. Part C, find a smaller interval that contains the value p. You must show calculations to support your answer. Well, what we have so far is our values of 3 and 4. What we want is a smaller interval. So we want a smaller interval. Something a bit bigger than 3 but a bit smaller than 4. So we could have, for example, 3.1 and 3.9. So let's work out what f of 3.1 is. We would have 3.1 cubed, subtract 7 times 3.1, subtract 12. So let's work out what this is. So I've got 3.1, and if I store this into my calculator, put 3.1 cubed, subtract 7 times 3.1, subtract 12, which is negative 3.909. And if I work out what f of 3.9 is, I would have 3.9 cubed, subtract 7 times by 3.9, subtract 12. So if I work out what this is, I've got 3.9 cubed, subtract 7 times 3.9, subtract 12. So I get 20.019. So, because again, f of x is continuous and we've got a change in sign, we've got something negative to something positive, we can therefore conclude that we have our new interval 3.1, which is less than p, which is less than 3.9. Question number 10. Two vectors A and B are shown on the 1 cm grid below. We have to show that the vector A plus 2B has a length of 7. You may use the grid below. So there's a couple of ways we could do this. One way is to literally copy and paste these into the grid and add them together. So what I mean by that is, here I've got the vector A, okay? I've got the vector A here. Let's just move it down somewhere here. And what I need to do to vector A is add on twice vector B. So I've got vector B here, okay, and what I need is two of these. So there's one of them, and here is the other. So I've got A plus 2B, and the result of that is this vector here, which is A plus 2B. So for us to work out the magnitude of this vector, well, I've got 7 lines up and 0 across, so the length is equal to 7. Question number 11. The diagram below shows two triangles we have to prove that triangle ABC is congruent to the triangle ACD. So the first thing we can do is find out these missing angles. We can begin by finding the angle BCA, which is this angle here. So the angle BCA, that's equal to 180, subtract the 80 degrees, subtract the 56 degrees, which is 44. So this angle is 44 degrees. We can also find out this angle ACD. The angle ACD is 180, subtract 80, subtract 44, which is 56. So this angle is 56 degrees. And we also know that this is common to both. So AC is common to both. So what do we have here then? Well, we've got a situation of angle side angle, so therefore the triangles are congruent. Question number 12. The diagram below shows two right-angled triangles. That's what we see here. We have to prove that triangles PQS and QRS are similar. So, what we can do to begin with is work out what QS is, and we can do that using Pythagoras. So, QS equals 4 squared plus 8 squared square rooted. So what this is equal to, 4 squared plus 8 squared, that's 80, and if I square root that, I get 4 root 5. We'll just leave it as square root 80. And with this, let's just add this to the diagram. I've got here square root 80. With this, I can find out what PQ is. PQ, that's equal to 10 squared subtract root 80 squared square rooted. So I've got 10 squared subtract root 80 squared, and then square root that, I get root 20. So I've got root 20. So this length here is root 20. So we need to show that the triangles are similar. So for us to show that they are similar, we need to use the scale factors of the triangles. So let's draw out two triangles. So we've got two triangles here, and we've got our right angle here. So I've got R in Q. I've got Q over here. And I've got S here. And then I've got S over here. And then I've got P over here. So what are these lengths? I've got QS, which is root 80. So I've got root 80 here. And then I've also got the root 80 here. And then I've got QR, which is 4, or 4 here. And I've got QP, which is root 20. And then I've got RS, which is 8. And then I've got SP, which is 10. So for me to have similar triangles, the scale factors need to be the same everywhere. So I've got this side, which corresponds to this side. So what's the scale factor in that case? Well, I would have root 20 divided by 4. So if I work this out, I've got square root 20 over 4, which is 5 root 2, root 5 over 2. Think about this side and this side. That's a similar thing. I've got root 80 over 8. So if I work out what this is, I've got 5 square rooted over 2. And then if I think about the hypotenuse, this and this, I've got 10 over root 80. Which is root 5 over 2. So what can we say here then? I've got root 5 over 2, which is my scale factor, which means the triangles are similar. Question number 13, part A. Calculate the volume of a sphere with radius 6 cm, and the volume of a sphere with radius r is v equals 4/3 pi r cubed. So the volume that's given by 4/3 times by pi times by 6 cubed. So if I work out what this is equal to, I have 288 pi. Part B. An ornament is made from a solid glass square base pyramid. The base has side length 15 cm. A hemisphere with radius 6 cm is cut out of the base of the pyramid. This reduces the volume of glass contained in the ornament by 30%. And what we have to do is calculate the perpendicular height of the pyramid. The volume of a pyramid is given by a third times by the area of the base times by the perpendicular height. So what we can do to begin with is find out the volume of the hemisphere. The volume of the hemisphere, that's going to give half times 288 pi, which is 144 pi. So that's the volume of the hemisphere. Now, what's happening over here? Well, what's happening is we cut out a hemisphere from this pyramid. So, in doing so, the volume of the pyramid is reduced by 30%. So, let's work out the volume of the pyramid. The volume of the pyramid is a third times by area of the base, which is 15 times 15 times by the perpendicular height. We'll call that perpendicular height, h. And the volume of this, that's going to be given by, well, we can leave this as, well, I've got a third times 15 times 15, which is 75. So here I end up with 75h. So what's happening over here? The volume is reduced by 30%. Okay, so with that 30%, what I need to do is multiply this 30%, which is 0.3, by 75h, and this is 144 pi. So I can find out what h is. That's given by 144 pi over 0.3 times 75. And if I work out what h is in this case, I get 32 pi over 5. Question 14. Part A. Standard bricks have dimensions 21.5 cm by 10.3 cm by 6.5 cm, correct to one decimal place. A house is built using 4,663 standard bricks. Jocelyn says, placed end to end, the bricks from the house would definitely reach over 1 kilometer. Show that Jocelyn's statement is correct. Well, let's convert the 1 kilometer into centimeters. For me to do that, I've got the 1, and if I times this by 1,000, that converts it into meters. And then if I times this by 100 to convert it into centimeters, I end up with 100,000. So I've got 100,000 centimeters. The minimum length of the brick, well, that's going to be 21.45 centimeters. Remember, these values are rounded to one decimal place, so I need the lower bound. So I've got 100,000 divided by 21.45. So if I work out what this is equal to, I get 4,662.00, etc. And because this is less than the 4,663, this statement will be correct. So, this statement is true. Next, part B. A standard brick should weigh 2.8 kilograms, correct to one decimal place. A truck can carry a maximum load of 20 tons. For the first part, calculate the maximum number of standard bricks that the truck should be able to carry. Now here we need to follow a similar procedure. We've got this 20 tons. And this 20 tons is the same as 20,000 kilograms. Now we've got this weight being 2.8 kilograms to 1 decimal place. Now I need to calculate the maximum number, so what I need is the upper bound of the weight. So that's equal to 2.85 kilograms. So I've got 20,000 divided by 2.85, which is equal to 7,017.54386. So the maximum number that will be given by 7,018. Next we have to explain why the answer to part B may not be possible to achieve. Well, if we think about our truck's going to be limited in size. So there may not be enough room in the truck. Question 15. Ratner invests 1,200 for 2 years in a bank paying R% per year compound interest. At the end of 2 years, the amount in a bank is £1,379.02. Calculate the value of R. So, we've got our original amount, 1,200, and I need to multiply this by our multiplier. If we are investing R%, our multiplier will be 1 plus R over 100. We are investing for 2 years, so we raise this to the power of 2. And the result of this is 1379.02. So, I've got 1 plus R over 100 squared. And this is equal to 1379.02 divided by 1200. And it turns out I get 1.149, etc. So I've got 1 plus R over 100 equaling the square root of this, which is 1.0719. And if I take away 1, I get R over 100 equals 0.0719, etc. So if I multiply this by 100, I get R equals 7.199, etc. So that is the value of R. Question number 16. The box plot shows the distribution of the salaries for the workers at Bexbridge Biscuits. Part A, state the median salary. Well, the median will be the middle value. So that is this value here. And that corresponds to 37,000. Part B, we have to find the interquartile range. The interquartile range is the upper quartile subtract the lower quartile. So the interquartile range is the upper quartile, which is this value, subtract the lower quartile, which is this value. So I have 43,000 subtract 21,000. So that's 22,000. Part C. The following salary information is true for workers at Comfort Cookies. The highest paid worker earns 85,000. The lowest paid worker earns 20% of the salary of the highest paid worker. 25% of the workers earn more than 50,000. 25% of the workers earn less than 28,000. The median is 37,000. We have to draw a box plot for this information. So we've got the highest paid worker earning 85,000. Then we've got the lowest paid worker, which is 20% of this, so I've got 0.2 times 85,000, which is 17,000. So 17,000 is 15, 16, 17 is here. So there's the lowest paid worker. I've got the median, which is 37,000. And then it says 25% of the workers earn more than 50,000, so that is the upper quartile. And then it says 25% of the workers earn less than 28,000, so that will be the lower quartile. So if I complete my box plot, here is my box plot. Now for part D, we have to make two different comparisons between the distribution of the salaries at Bexbridge Biscuits and the salaries at Comfort Cookies. So in terms of the interquartile range, in this case, we have 50,000 take away 28,000, which is 22,000. So let's just write that down, but let's show it. Here, I've got an interquartile range of 22,000. Whereas here I had an interquartile range of 22,000. So the interquartile range is the same, so they've got the same consistency. And we know that the median is 37,000 for Comfort, and the median here was 37,000. So both have a median of 37,000. Question 17 here is a function. So we've got function A, input at 14 times 5, we get an output. The output of function A is x. We have to write an algebraic expression in terms of x for the input of A. Well, it's an expression. So what do? Well, we take our input, we then add 14 to this. After that, we multiply by 5, and then we get an output of x. So I've got input equals, well, plus 14 equals x over 5. So my input equals x over 5 subtract 14. So what's my expression? Well, my expression is x over 5 subtract 14. Part B, a number k is put into function A. The output is also k. We have to find the value of k. So the input is the same as the output. So what happens here is, I've got k, I add 14 to it, I then multiply by 5, and the output is still k. So I have to work out what k is. So let's expand the brackets. K times by 5, that's 5k. 14 times 5, that's 20. Or rather, it's 70. And then here, I've got k. 5k subtract k, that's 4k. 4k is equal to negative 70, and if you divide through by 4, k is equal to negative 17.5. Question 18. Percy sells pin in standard tins and large tins. A standard tin covers 40 meters squared and the large tin covers 60 meters squared. Part A. Percy publishes this chart showing the area that can be covered with each tin of paint. Part A. Explain why the chart is misleading. Well, if I take a look at this width, and then if I take a look at this width, what you can see is that they are different. So why is it misleading? Well, the bars have different widths. Part B, the standard tin and the large tin are mathematically similar. The volume of the large tin is 50% more than the volume of the standard tin. Both tins are cylinders. The radius of the standard tin is 10 centimeters. We have to calculate the radius of the large tin. So, from this statement, what we can see is the volume scale factor is 1.5. So, what I need to do is calculate the radius of the large tin. I know the radius of the standard tin, that's 10 centimeters. So what I can do is find out the length scale factor. The length scale factor is equal to the cube root of the volume scale factor. So I've got the cube root of 1.5. So what I can do now is find out the radius of the large tin. So for the radius, that's equal to 10, which is the radius of the small tin. And I'm going to multiply this by our length scale factor. So let's work this out. I've got 10 times by the cube root of 1.5, which is 11.447. So that is the radius of the large tin. Question 19, we have to show that 2x squared plus 13x plus 20 over 2x squared plus x subtract 10 simplifies to x plus a over x minus b, where a and b are integers. So let's think about how we could do this. Well, we need to factorize the numerator and the denominator. If I think about my numerator, what I'm after are two numbers which multiply to give 2 times by 20, which is 40, which add to give 13. What are those two numbers? Well, I've got 8 and 5. So, I've got 2x squared plus 8x plus 5x plus 20. 8x plus 5x is 13x. So if I factorise the first two terms, I get 2x. And then inside the bracket, I would have x plus 4. Here I also want an x plus 4. X plus 4 multiplied by 5 gives 5x plus 20. And if I group the terms together, I end up with 2x plus 5 multiplied by x plus 4. So that's my numerator. Let's consider the denominator. Well, for the denominator, I need two numbers which multiply to give 2 times by negative 10, which is negative 20, and which add to give 1. What are those two numbers? Well, we have negative 4 and 5. So, I've got the 2x squared, and then I'm going to subtract 4x, then add on 5x, then subtract 10. So factorising the first two terms, I end up with 2x, and then inside the bracket I've got x subtract 2. I also want an x subtract 2, and if I multiply this by 5, I end up with 5x subtract 10. So when I factorise, I end up with 2x plus 5 multiplied by x subtract 2. So when I come to simplify, well, I've got this expression here, and what this is equivalent to is 2x plus 5 multiplied by x plus 4 over 2x plus 5 over x subtract 2. So I've got 2x plus 5 on the top and the bottom, simplifying to 1. And then I end up with x plus 4 over x subtract 2. And that's what we wanted to show.